And part of it has to do, perhaps, certainly, the global weather system is all driven by the conveyor, the global conveyors that run all of the warm water from the equatorial area up to the northern latitudes, and it mixes, and the saline, the salt water from the ocean, mixes with the fresh water from the meltwater from the ice and so on, and then it gets heavy and it goes down below and it gets warm again and it goes up and down. And if that system changes, the whole global weather changes. And what scientists now are monitoring and saying things like the Gulf Stream here is starting to slow down, and it suggests that maybe the whole system is starting to change. So what happens if you get increased warming? Well, you've heard about all the, you get more ice, and the ice melts, and you get more water into the oceans. And so if you get about 2.5 degrees centigrade more temperature increase, which is thought to be somewhere around 2030 or 2025, it's at the present rates, could be faster. You get something like this. This is Manhattan, right? Here's Manhattan with 2.5 degrees of temperature rise. It's all underwater, all the blue stuff. New Jersey is not a good place to live. Long Island, it's problematic. Here's Seattle. Looking north at Seattle, you've been there, you've seen that? It all goes under, all the industrial areas south of Seattle goes underwater. So, this is a big deal. If you got Florida land, this is a good time to sell it. And these impacts is not just in terms of the water going up and all that kind of stuff. This is multidimensional. It works its way across food and water and ecosystems and so on. And when you get up here about 2.5 degrees of centigrade, you start getting into decreases in water availability, rising number of species, extinction, intensity of fires and storms, and risk of dangerous feedback, and so on. This is a big, big, big deal. This is serious, for whatever reason that it's happening. So it's been going up for the last 50 years or something like that, and then you've got this problem. The temperature monitors report wide-scale global cooling. What? We said global warming. No. In the last year, it lost 20 years worth of, here's the trend. It's going up, getting hotter and hotter from 1988 to 2008. And the average is kind of working its way up like that, and it went from a peak there to the coldest year in the last 20 years was last year. And you say, what in the world is going on? There's an interesting point here that I want to make, and that is that none of this is predictable. That this is all nonlinear and unstable and all other kinds of things, and you don't know for sure what's going on, and you can't just drive extrapolate a trend out into the future. You can't do that in any number of these kinds of things. And so you've got amazing kind of thing. Now maybe this is just instability from the system starting to become unstable and going somewhere else. Who knows what it's going to do? But the fact of the matter is that this is big kind of swings and big kind of changes that are coming here, and it's hard. It's impossible to tell exactly what's going on. For instance, there is really good multi-source information, if you want to look for it, that suggests that all of this global warming is coming from volcanoes under the ocean. That there's an increasing number of volcanoes and they're going off and they're heating up the ocean, and that's what's generating all of this global warming. And it's going to get worse. And then if you go look into that and you think about that, what you find out is that there's big dead spots in the ocean that they've found, where there's no life and no fish, no nothing. And you say, what's going on? And if you think, but maybe there's volcanoes, well, they could be putting up all kinds of toxic gas and killing everything up above the thing. So maybe that's what's doing it. In any case, there's lots of very interesting, large-scale stuff going on here. The sun is doing weird things. The sun is going into fluctuations and doing stuff it hasn't done, people haven't seen for a long time. the human resonance, the frequency of the planet Earth, which is the kind of the natural resonant frequency of the planet, has been the same for hundreds of years. And in the last 10 years, it's increased from 7.5 hertz up to about 11 hertz. I mean, suddenly there's things moving. This is big things going on. More good news? Global pandemic. There's a possibility, we're kind of due for a big epidemic, a pandemic, and a lot of people die of flu. You've always heard of the bird flu. So the last big time that you had a big epidemic was in 1918 when the Spanish flu, and they've had lesser ones going forward. But the interesting thing about the whole kind of the profile of how this happens is that here's the literal curse from a very kind of nice original graph from 1918 and 19, and what they show is in New York and London and Paris and Berlin that the death rate was all between about 6 weeks, right? About 2 months. So if you think about that, what it is just a big shot to the system very quickly. It shows up and frankly scares everybody to death, and they quit working and they don't go to work and they go back and hole up in their house waiting for the whole thing to go over with, and then the electricity quits and the water system quits and other kinds of stuff. So there's a lot of secondary kind of effects that come out of all of this. It's the last time there was about 50 to 100 million deaths. Now the predictions are somewhere, they've done the computer modeling of this and they've looked out, and it looks like somewhere between 360 and some say up to 1.2 billion that might die of this thing, if it really happens the way it happens. The problem is, again, and the thing that's different from 1918 is we got airplanes, right? And you've got a latency period, so somebody gets this flu and they climb on an airplane and they end up the other side of the world, 18 hours later. And you don't know they got the flu until maybe 3 or 4 days later, and by then they've infected a bunch of people. I had a friend of mine at the Pentagon who said they did some gaming and some theorizing in the Pentagon about bird flu, and they found out that the president has 2 days. 2 days from the first time that he's got the inkling of somebody come into this country that's got the bird flu to shut down the whole air traffic control system. I mean, think about the political implications of somebody trying to make a decision to shut down the whole economy of the United States, if you will, almost, based upon some report that somebody's coming in. But that's what you got to do, because if he doesn't catch it within 2 days, then it spreads and it can't catch it. How bad will the epidemic be? Well, it's as bad as 500 Katrinas, this group of scientists says. Big deal. It could kill 1.5 billion people, and already it appears in Pakistan that it's mutated to where it's humanly transmissible, and it's moving itself around the world. But there are breakthroughs, by the way. There are really big changes. There's wonderful kind of things. I mean, don't get all funky and all depressed, because I'm going to come to the end and tell you how to fix all this. I mean, I am. Believe me. Don't leave yet. Yeah. There are amazing kind of breakthroughs that are coming along at the same time. Artificial general intelligence, what you've got is amazing kind of increases in the capability for us to solve problems with technology, with computers, essentially. And if you follow the progression of the evolution of computer power and cost, and this is the kind of the technological advancement that you asked about, that you get, if you go back to 1900 and look at remember those machines, those Monroe calculators? You remember those? Any of you old enough? I remember that. Anyway, mechanical kind of things, and there's the UNIVAC and the UNIVAC and the Mac 2 and the Gateway and so on. And they're all riding up this line. And what they say is that somewhere by about there, which is about 2015 or so, you get the equivalent of a human being in 1,000 of a human being in 1,000 computing power in a $1,000 computer. So what? We're less than 10 years away from a single computer having the computing power of a human being. But we're riding this exponential curve, right? Amazing kind of increase. And so what happens is that it doesn't just go linearly up. If you did Moore's law on this linear scale, on this geometric scale, Moore's law, which is what I just described on that other slide, says that it'd go up like this. But no, now we've got quantum computers, and quantum computers are just screaming for the sky like that, and that's what Ray Kurzweil is saying is going to, in fact, drive a lot of the change that we're seeing, that we're going to see. And what he says is that there's a place about 2039 when a single computer is more powerful, is 1 billion times more powerful than all the human beings on the planet. In 2039, a single computer is more powerful than all of the human beings on the planet. And about then we start working for them. Yeah, he believes it. He says, you know, they're all connected and they're all networked and they run everything because, you know, that's what we use them for. And you finally say, hey, let them go to do it. We'll have some questions at the end. You know, that's what he thinks is his singularity. And that's what a singularity is. Some amazing thing that happens that just drives, and we all become different humans. I mean, it's a different kind of place. I don't know. How far are we from artificial general intelligence? Artificial general intelligence, everybody here knows what artificial intelligence is, because every time you try to make an airplane reservation and you get a disembodied voice that tells you punch 1 or punch 3 or go that's artificial intelligence, and that's called expert system because it's expert at one thing. All it'll tell you how to do is punch buttons and do these kinds of things, right? But artificial general intelligence is software capability that will solve general problems. Which is to say, it's like an intern or a research assistant or something, and you just kind of put them on a project, they learn about it, and then they get smart about it. So it's generally applicable, and you can use it wherever you want to. How far are we from it? They say, less than 5 years, probably maybe 10 years. What's that mean? Well, think of 100,000 PhD level researchers focusing their total efforts on life extension and anti-aging. That's the idea. You just layer on one after another to solve a problem. I mean, we got some problems, right? So you layer all these things one on top of each other, and suddenly you've got the capability for doing problem solving unlike anything you've ever seen before. I mean, it's not like all this stuff is coming and you just got to sit there and wait. No, there's amazing kind of capabilities that are increasing to allow us to be able to solve some of these kinds of problems. In education, imagine millions of highly competent, low-cost teachers available to people everywhere. You know, you can just extrapolate this out all kinds of places in terms of simulation, being able to make sense out of systems and things that you can't understand now. You'll be able to predict the weather 3 years from now at 3 o'clock in the afternoon out in front of the ice house. You know, I don't know. There's just things that we all take for granted and presume is impossible to do that we're on the verge in the next decade at least of being able to do, that you just are crazy in the way that we think about them. That's, by the way, a characteristic of the process and the transition we're going through, is that the world that we're coming into makes no conventional sense from this perspective. I'll talk to you a bit about it, but we're working into some space that is non-rational, you know, that we've never seen anything like this before. We don't have the history, we don't have the experience to kind of work our way into that space in any kind of logical kind of way.